In this problem, we're given the three sides of a triangle and asked to solve it, which means find those missing angles also. Notice how there are no names here. That's okay. If you're given a triangle without labels, call them whatever you want. One thing that is helpful, not mandatory, but helpful, is if you get in the habit of calling your biggest angle C. It's just, if you're consistent, it makes it a little bit easier for you. So we can say that side A was 9, side B was equal to 7, and side C is equal to 15. Well, we don't have an angle side pair. Obviously, we don't even have any angles at all. So we're going to need to use the law of cosines. And that means we have a choice. Which angle are we going to find? My advice to you, and although you can use the law of cosines to find any angles and you'll get the right answer, my advice to you is look for the biggest angle with the law of cosines. The reason for that is because the law of cosines can find an obtuse angle. So if C turns out to be obtuse, which it looks like it in this picture, the law of cosines will be able to find it. The law of sines cannot. So if I were to try and find one of the other angles with the law of cosines, and then use the law of sines to find angle C, I would get the wrong answer. The law of sines cannot find an obtuse angle. So let's use the law of cosines. We are looking for angle C, which means I'm going to need to use the setup for the law of cosines that includes the angle C. Well, that's the one that has the C squared by itself. Remember the angle that's in the cosine at the end and the side that's by itself, they match up. So it's C squared equals the sum of the squares of the other two sides minus 2 times AB times cosine of C. And we can fill in the information that we have. 15 squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. And so if we want to figure out what angle C is, we need to first get the cosine by itself, and then we'll use inverse cosine to figure out what the angle is. A word of caution about the math you do here. These are numbers you should know in your head. 81 plus 49 minus 14 times 9. Good trick for multiplying things by 9. Just multiply 14 times 10, 140, and take away a 14. That means there's only 9 of them. So we go from 140 down to 126. So that's a quick way to multiply by 9. One thing you have to be careful about here, as I just finish up that 81 plus 49, is make sure that you keep in mind that order of operations never go away. Those are rules we don't break. So I cannot subtract 130 minus 126 because the 126 needs to be multiplied first. So what we can do instead is move the 130 over. And so we get 95 is equal to negative 126 times the cosine of C. And so cosine of C equals negative 95 over 126. And you might look at that and say, wait, cosine is negative? That's going to be an error, right? No, cosine can be negative. Sine can also. We'll talk about that after spring break. But it is okay that cosine of C is negative. We'll let Desmos handle that. We're going to say that angle C is equal to the arc cosine of whatever that fraction is, negative 95 over 126. We'll let Desmos tell us what that angle is. Arc cosine, and remember, arc cosine is tricky, there's 2 C's in there. Arc cosine of negative 95 over 126. That is 138.9 degrees. Keep in mind that you do have to do a quick check. Make sure you're in degree mode. Had I been in radian mode, well, that doesn't seem right. 2.4 degrees? No, you'll notice if you use arcsine or arccosine in radian mode, you'll notice that it's not quite right. So degrees, so 139 degrees, and so we will go back to our diagram and say that is 139 degrees. We can put that in here. And we have found the first angle. If you want to, you can repeat that process to find angles A and angles B. So you can use the law of cosines again to find the other angles. I just about always prefer to use the law of sines because I think it's faster and easier. So I'm going to try and find, and now that I found the obtuse angle with the law of cosines, it doesn't matter which of the other angles I find the law of sines, it'll work. So I'll find angle A. Sine of angle A over 9 equals the sine of my 139-degree angle over C. And so angle A equals the arc sine of 9 times the sine of 139 over 15. And just remember that when I go to Desmos, I'm not going to use that 139. I'd rather not use the rounded number. So if I call this C, now I can say that A is equal to the arc sine of 9 times the sine of C over 15. So I don't have to worry about rounding the numbers or anything. There we go. A is 23.2 degrees. So I'll write that in here. Again, it's fine to angles you can round to the nearest degree. And again, I know 2 angles. That means I know 3. So we'll find the third angle the easiest way possible. Again, if you set up law of sines, it'll work. If you set up the law of cosines, it'll work. But why make life hard? Just do 180 minus A minus B. And I could do that subtraction without Desmos, but I want to make sure I'm rounding everything correctly. So 180 minus A minus C, and that gives me 17.85, which will round to 18 degrees. A quick note that because we've rounded 3 numbers, there are times when if they all round down, you might end up with 3 angles that look like they only add up to 179, or maybe they look like they add up to 181. That's okay. That doesn't mean you're wrong. Sometimes that's just how rounding works.